We are starting out trigonometry. In this first section, I'm going to go through a review of what you've done in geometry already, talking about right triangle trigonometry. Before I even get into that, I want to do a quick refresher so that you don't always think you have to use trig to go through and solve right triangles. So in this problem, we have one side that's 3, one side that's x, and one side that's 5. So think back to geometry. And how would you normally have solved this problem before we ever introduced trig? And it's a Pythagorean theorem. A squared plus b squared equals c squared. Remembering that a and b are your legs and c is your hypotenuse. Your hypotenuse, remember, is always the largest side. It's across from the largest angle, which is your right angle. So 5 is always going to be that hypotenuse in this problem. I know it is. It's across from that right angle. So using the Pythagorean theorem, I substitute in a I can use as 3 squared plus b, which is my x, squared equals my c squared, which is 5 squared. So I'm trying to figure out what x is. Now, I could have done x squared plus 3 squared equals 5 squared, remember? But what I'm adding, it doesn't matter which direction you go. So 9 plus x squared equals 25. Subtract x squared is 16. I'm finding a length, so when I square root, it's just the positive length. So that third side is just 4. This is one of those special triangles. It's a 3, 4, 5 triangle. It gives you those nice Pythagorean triples. So keep in mind, if you have a right triangle, I give you 2 sides. Just do the Pythagorean theorem to find the third side. Whether you're finding a hypotenuse or a leg, it doesn't matter. But keep in mind, this is the easiest method to do without having to jump into trigonometry. So we're going to look at right triangle trigonometry. Before we do this, we are going to have to take a look at a specific angle. In trigonometry, we're looking at an angle and 2 sides. Sometimes we're going to be finding a side length given a side and an angle. Other times we're going to be finding an angle given 2 sides. Other times we're going to solve the whole thing. So if that's the case, I need to label an angle. I'm going to call that one theta. Theta, beta, all Greek letters, we tend to start using when we're looking at angle measurements. X, Y, Z, W, those are usually side lengths. So angles we start to use Greek letters with. So if this is my angle I'm using, I automatically know my hypotenuse is across from my right angle. And then, since my angle is in this corner here, the side that doesn't touch it is opposite, and the side that touches it is adjacent. Now, it's important that you know those words because of how sine, cosine, and tangent are defined. The sine of your angle, so the sine of theta, sine is opposite over hypotenuse. It's a fraction. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Tangent is opposite over adjacent. So sine is the shorthand version, S-I-N-E, cosine, and tangent. Sine, cosine, and tangent are dealing with an angle. That's why it says sine theta, cosine theta, tangent theta. There is a theta after each of these, and it's just the ratio of 2 specific sides. It's a ratio, fraction. And a shortcut to remember this is SOHCAHTOA. If you want to see some great videos that students have made over the years, search YouTube and look for SOHCAHTOA videos. And there are some awful songs that they go with it. But if it helps you remember SOHCAHTOA, you have to remember which ratio it is. Sine is opposite over hypotenuse. Cosine of your angle is adjacent over hypotenuse, and tangent is opposite over adjacent. So those are 3 you're used to, you should be very familiar with. Then we have to feel comfortable with the other 3. The reciprocals, the reciprocal functions, the reciprocals of our three trig functions. So with sine, cosine, and tangent, we just did those. So sine is opposite over hypotenuse. Sine's reciprocal is called cosecant. And cosecant is represented with CSC, and it's just cosecant theta, of course. And then SEC is the secant, which is the reciprocal of cosine. And then COT is cotangent. Okay, so those are the reciprocal functions of sine, cosine, and tangent. You don't have to memorize three more. You just need to know how to use sine, cosine, and tangent, and you can instantly get the reciprocals. So cosecant theta is the same thing as 1 over sine theta. It's the reciprocal of it, which is the same thing as opposite over, not opposite over hypotenuse, which is the same thing as hypotenuse over opposite. Secant is the reciprocal of cosine, which is hypotenuse over adjacent. And cotangent is the reciprocal of tangent, which is adjacent over opposite. So it's just simply the reciprocal of each of those. So if I ever ask you for a ratio, it's just the reciprocal of the initial one. So if you do your three main trig functions, then you can do the reciprocal to find the other three. So in this case, I'm asking for the 6 trig ratios. So I want sine of theta, cosine theta, tangent theta. Cosecant, secant, cotangent. So pause it and come up with those. So if you started to try to do this, you realize there wasn't theta to compare it to. So there's your theta. It's in the bottom left corner. If you put it in the top, they're all going to be reciprocals because they're for opposites and adjacent sides because those will be flip-flopped around. So if you put your theta in the bottom left corner, you should get the following 6 trig functions. So there are my first 3. And then I take the reciprocals of them. Now keep in mind, you need to make sure that sine and cosecant are reciprocals of one another. You have to know which one goes with which. So those are your 6 trig ratios. It's just the cosine, sine, tangent of your theta equals its specific ratio. Now to help you keep track of which one corresponds to which, because as I said, you're going to have to remember this, the easiest way I can say it, tangent, cotangent should be very straightforward. Then you would just have to remember the difference between sine and cosine with cosecant and secant. Here's my trick for you, no mathematical merit behind it. Cosine starts with a C, ends with an S. Secant starts with an S, ends with a C. So it's one way to help you keep track of them so you know which one goes with which, but make sure you understand which one is the reciprocal of the other one. So now that we know how to set up our trig ratios, now we should be able to solve triangles. If we're going to solve a triangle, we need to find all angles, all sides. So I have 2 angles we need to find in this problem, and then I'm giving you 2 sides. Keep in mind the easiest way to find a third side given 2 sides is doing the Pythagorean theorem. So I'm going to start by doing the Pythagorean theorem. 5 squared plus x squared equals 13 squared. 169, 25, subtract 25, square root. X therefore equals 12. This is another one of those special known triangles. It's called a 5, 12, 13 triangle. So I have my 3 sides now. The last thing I have to do is find my angles. So to find my angles, this is where we have to use SOHCAHTOA. So specifically, we're going to pick one angle to find. It doesn't matter which of the 2 we find. They're both the same complexity. So I'm going to find this theta down here. So if I'm going to use that theta, I'm going to have to then pick 2 other sides to work with. Now, a rule of thumb is use the sides you didn't have to come up with in case you messed up. I'm going to try not to use this side that's 12, just in case I messed up the 12. So I'm going to use side 5 and side 13. So according to this angle, 5 is what side? Opposite, it's not touching. And 13, of course, is a hypotenuse because it's opposite your right angle. So I have opposite and hypotenuse. So now I have to think about what uses opposite and hypotenuse. So the sine of theta equals my opposite over my hypotenuse. So sine theta equals opposite, which is 5, over hypotenuse, which is 13. I have to find my theta. So now I have to look at, well, what's attached to theta? Theta is attached by sine. So if you look at your calculator, find the sine button. And right above the sine button is this inverse. Now that we've started talking about inverses in here, this should start to make sense. I have to undo sine. What undoes sine? Sine inverse. So what I do to one side, I also must do to the other side. The sine inverse is the only thing that cancels out a sine. So those go away, and I'm simply left with theta on the left-hand side equals sine inverse of 5/13. So therefore, I plug this into my calculator, and I end up getting 22.62 degrees, provided your calculator is in degrees. If your calculator is not in degrees, you're going to need to click your mode and see this third one down. Now radians is flashing. We're going to talk about radians later, but it needs to be in degrees. So if it's not in degrees, arrow down, arrow over to degrees, and hit enter, because I want my degree measurement. So it's sine inverse, so second sine of 5/13. Then you get that 22.62 degrees. So that's my measure of angle theta, which is 22.62 degrees. Now, I need to find beta as well. So if I use beta, my sides are no longer opposite from it. That side is now adjacent. Hypotenuse is still my hypotenuse. So that I can now set up something using adjacent hypotenuse, which of course would be cosine. So cosine theta equals adjacent over hypotenuse, inverse cosine, both sides. Then you get 67.38 degrees. Did anybody try it a different way? Now, you could. How many degrees are in a triangle? 180. 90 of them are already taken up by there. I found out that was 22.62 degrees, which leaves me with beta at 67.38 degrees. Now, I did just state, try not to use something you found in case you made a mistake. But this is one of those cases where subtracting it is super quick compared to actually going through the whole process. So, back to this one for a second. So I solved my triangle. I found every side and every angle. You don't always have to do that much work. You may just be finding bits and pieces of it. In this problem, for instance, I'm giving you a 90-degree angle. I'm giving you a 20-degree angle. I'm giving you a length of 5, and then my x and y. When you're finding two different sides, just set up your triangle separately. Here's my angle, and according to this is adjacent to it. This is opposite. If it messes you up, draw a separate triangle out. This is 20 degrees. This 5 is adjacent. And then I have my y, which is my hypotenuse. Adjacent hypotenuse, use cosine. Opposite adjacent, use tangent. So go through these two problems and find your x and y values. So I have the setup for both of them. I'm going to work the left-hand side down. I multiply both sides by 5. In my calculator, I take the tangent of 20, multiply it by 5. X is 1.82. So that's a length of side x. And then over here, I've got to get y by itself. I can't have y in the denominator. So I got to get y out by multiplying both sides by y. So I have y times the cosine of 20 equals 5. Now I got to get rid of cosine 20 because y I see by itself. Make sure you divide correctly. Don't assume that you're doing it right. Do the math behind it. So when I take 5 and divide it by the cosine of 20, I get 5.321. So now I need to look at this. Y is 5.321, and then x is 1.82. Make sure these legitimately make sense. Opposite from my largest angle is my largest side, so my hypotenuse has to be the largest. I have a 20-degree angle here, which means this has to be a 70-degree angle, because there has to be 180 degrees total. So 70 degrees is my middle angle, middle side, smallest angle, smallest side. So they correspond, so I did them correctly. So these are all the different types of ways you can solve right triangles, finding angles, finding sides, and remember, just do the Pythagorean theorem. Go back and practice, if I can find it, these 6 trig functions. Make sure you get comfortable with these new ones.